and welcome back to Algebra 1. Our goal for today is to start to look at actually solving our multi-step equations. These are equations that are bigger or more complex than a one or two step equation, which require our essential skills that we reviewed in our last lesson of can I expand using the distributive property and can I simplify by combining like terms. Once I've done those two tests, I've expanded and simplified or combined like terms, I'll be back to either a one-step or two-step equation that I do know how to solve. So at this point, I should understand that an equation is a mathematical problem that has an expression, then an equal sign, and an expression. That's the type of problem we're going to be solving today. Over the next few days, we'll also add in our multi-step inequalities, which are in the format of expression, one of our four inequality signs, expression. So again, for today, our problems are going to be bigger and more complex than a one or two step. And the way that we get it back to either a one or two step problem is by distributing and combining like terms. So take a second, fill in your blanks. How we go about solving multi-step equations. All right, your inverse operations for today have not changed. So what's originally presented as addition will require subtraction to remove. What's originally presented as subtraction will require an addition as an inverse operation. If the original has multiplication, it will require a division to help us solve. And if the original is a division, it will require a multiplication. The only thing that is new today is I need to try to get the problem back to a one-step equation or a two-step equation by simplifying first. So let's look at some examples. Number one. All right, we looked at this type with our two-step. It's really the most basic type of multi-step problem because it does require some expanding using our distributive property. So in this case, we started with taking our 12 times and sharing it to our 2 and minus or subtract x. And we ended up with a 24 minus 12x equals 6. And then since there was no like terms at this point, we said, all right, we're back to, in this case, a two-step problem. And we know that by inside our box over here, we have a plus or a positive 24 we need to remove. And we have a multiplying by negative 12, which is going to require two inverse operations to help us solve. So we're going to start with our subtracting 24 from both sides. Cancel our 24. Most common mistake here, again, remember, will be to add 24 instead of subtracting 24. If I have a plus here, those 24s will not eliminate and we'll end up with a 48 instead of a 0 there, which is what we need. Now I have a negative 12x equals 6 minus 24 would just give us a negative 18. From there, we're not done because x is not completely by itself yet on one side of the equal sign. So we now have to deal with the fact there's a multiplication here, which is going to require an inverse operation of division, and more specifically a division, in this case, of dividing both sides by a negative 12. Be careful here with your signs. We have a negative divided by a negative, which will result in a positive, and more specifically a positive 1.5, or 1 and 1/2. All right, that's the most basic type of multi-step equation we can see. One that just requires an expanding using our distributive property. However, sometimes we need to combine like terms, and sometimes we need to distribute and combine like terms before we're back to our one or two steps. So let's look at some other types. So number 2, we want to solve here for the variable x when we're given that 7x minus 3x minus 8 equals 24. So this one definitely looks a little bit different than that first one because there are no grouping symbols and there's no place where we have to expand using our distributive property. However, it's still bigger and more complex right now than just a regular one or two step problem. And the reason is that we have some like terms we can combine before we get to our inverse operation. So we want to start there first. On this side with x, these two terms are like terms. They can be put together or simplified. So we want to start there. 7x minus 3x will give us a 4x. And then we still have the subtract 8, and we still have the equals 24. Now that we have the problem back in its most simplified version, when we look at our side here that has x, again, we can see there's two things in there. There's a times by 4 and a subtract 8, which means this is a two-step or two inverse operation problem to solve from here. I cover up my x term. What I can still see in my box of subtract 8 is what I need to remove first. So we need to get rid of the subtract 8 by adding 8 to both sides. Cancel on the one side, bring down our 4x, do our math on the other. So 24 plus 8 more would just give us a new total here of 32. All right, we're not done because x is not by itself yet on one side of the equal sign. So now we have to deal with the fact that there's multiplication here of 4 times x. So our new inverse operation would be to divide, and more specifically to divide both sides by 4. Cancel on the one side, bring down our x. 32 divided by 4 on the other side would just give us an x value of 8. Good final value with proper steps of work. All right, number 3. A little bit bigger, a little bit more complex than any of the ones we've looked at so far. We want to solve for our variable x here when we're told that 5x plus 3 times x plus 4 equals 28. All right, in this particular problem, we have parentheses, and we're going to have some simplifying to do before we get back to either a one- or two-step equation that we know how to solve. We must start with our expanding using the distributive property by sharing the 3 to the x, or more specifically 1x, and 3 to the 4. I'm going to bring everything else down there and change. So we have 5x plus 3 times 1x would just give us a 3x. 3 times 4 would give us a 12, and then we still have that the whole thing equals 28. All right, we're still not back to our most basic simplified version yet. So another step here is needed to add or combine our like terms. All right, so we can take our two terms here that have x and put them together. They're like terms. So 5x plus 3x would give us a total here of 8x. We still have a plus 12, and the whole thing equals 28. All right, now that we've done our distributing and our simplifying, we can see that on the side where x is, there's two things. There's a times by 8 and an add 12, which means this is going to take two steps or two inverse operations to help us solve. I cover up my x term. What I can see inside my box of add 12 is what we would need to remove first. So our first inverse operation will be to subtract 12 from both sides. Cancel on the one side, bring down our 8x. 28 minus 12 would give us a value here of 16. All right, from there, we're not done because x is not by itself yet. So now we have to deal with the fact that there's a times by 8 on the side with x. So we need to divide both sides by 8. Cancel on the one side, leaving us with x equals, in this case, a value of 2. All right, number 4. All right, when I solve here for the variable m, definitely the biggest, most complex one we've looked at so far. Before we can use our inverse operations, we need to get the problem back to its most basic, most simplified version. And the way to get there is to distribute and then combine like terms. So before I can combine like terms, I can't have parentheses in the problem. So our first line or our first step of work is to remove the parentheses by taking this 3 and sharing it to the 4m and the subtract 2. Now, over here on the left side, 63 plus 23, there are no parentheses, so there's no place to expand using the distribute property. So since this first step is for distributing, this side it will remain as 63 plus 23. We're not doing anything over there yet. All right, let's do our expanding or distributing on our other side. 3 times 4m would just give us a 12m. And 3 times negative 2 would give us a minus 6. And we still have a plus 8m. All right, we're definitely not back to the most basic simplified version yet because we still have some like terms that can get combined. And more specifically, we have like terms on both sides we can combine. So on our left side, these are like terms. We can put those together. They're just simply numbers that can go together. So 63 and 23 would give us a new amount over here of 86. That would give us our simplified expression in front of our equal sign. So now we want to do that same thing behind our equal sign. If there's any like terms over there. So we have a 12m and an 8m behind the equal sign that can get combined to simplify the second expression. So 12m plus 8m would just give us a 20m, and then we still have our subtract 6. And then once we get here, now that it's in its most basic version, if I focus over here on the right-hand side where our m's located, I'll see that there's a multiply and a subtract, which means it's going to require 2 inverse operations to help us solve from here. I cover up my m term. What I can still see of subtracting 6 is what we need to do the inverse of first. So we're going to start by adding 6 to both sides. All right, so we have our 86. We need to add 6 to it. Bring our equal sign down the middle. We have our 20 times m minus 6, and we need to add our 6 to it. All right, cancel on the one side. We'll be left with 20m. On the other side, 86 plus 6 would just give us a value of 92. All right, we're not quite done because m's not completely by itself yet. So now we need to get rid of a multiply, more specifically a multiply by 20. So our inverse operation will be to divide both sides by 20. We have our 92, we're going to divide by 20. And we have our 20m divided by 20. Cancel on the one side, we'll get m completely by itself. On the other side, we're going to divide, and we'll end up with a 4.6, or we could also put 4 3/5, which would be the simplified fraction version. Good final value of m. All right, last one. We want to solve here for the variable x when we're given the equation 4x minus 3 times x minus 2 equals 40 minus 19. Again, there's definitely some simplifying we need to do before we can go to our inverse operations here. So to simplify, we always start with if there's a place where we have to expand using the distributive property, which in this case there is. We have this negative 3 times that has to get shared to the 1x and the negative 2. Careful, this is negative 3 that's getting shared. Everything else is coming down unchanged because nothing else needs to be rewritten due to expanding using the distributive property. So we still have this 4x. Negative 3 times 1x will give us a minus 3x. Negative 3 times negative 2 would give us a plus 6. And then we still have our 40 minus 19. All right, our expanding using the distributive property step is done. Now we're looking on each side of our equal sign to see if there are like terms we can combine to simplify. So in front of our equal sign, we have 2 terms that both have x that can go together. 4x minus 3x would just give us an x plus 6. Now that's the easiest way to write it, x plus 6. Now the other way to write it would be to put 1x plus 6, which is perfectly fine. All right, on the other side, our 40 minus 19, those are like terms, and we can combine to get us a 21. All right, now that we're back in our most simplified version, when I look at my side over here that has x, I can now see the way that I wrote that there's only one thing inside there to do, so this is going to require one inverse operation. If I put 1 times here, there will be 2 things inside of there, and it will require 2 inverse operations to help you solve, but both versions will get you to the same exact result. I'm going to go like this. I'm going to cover my x and get rid of add 6, and I'll be done. So x plus 6 minus 6 equals our 21 minus 6. Cancel on the one side, we get x completely by itself. 21 minus 6 would just give us a value of 15. Again, if you have a 1x here, then you would show dividing both sides by 1 and end up right back to that x equals 15. You'll get to the same exact result. All right, I hope that helps you attack your work for today. See you guys later.